FHRPs. Those are first hop redundancy protocols, and there are three of them that we need to know about in our Cisco environment. There is HSRP, VRRP, and GLBP. First, let's take a look at HSRP, and that's going to help us better understand what these FHRPs are about. The idea behind a first hop redundancy protocol is making the first hop, in other words, the default gateway as we go from our subnet out to the rest of the world. We want to make that first hop redundant. For example, take PC1 on screen. It wants to get out to the internet, and we could physically point PC1 to a default gateway of 10.1.1.2. That's the IP address of R1, but that suddenly becomes a single point of failure. If R1 goes down, suddenly we don't have another way to get out to the internet. We could go via R2, but PC1 doesn't know about that. It would be great if we could have a virtual router that we point to that doesn't go away even if R1 goes away. And we're going to have this virtual router in this example with an IP address of 10.1.1.1, and that's what we point to as our default gateway on PC1. Notice that's not the IP address of either R1 or R2, but we could say that R1 is going to be the active HSRP router servicing that virtual IP address, and normally we're going to be able to go via R1. But if R1 goes down, R2 is going to be our standby router. Which begs the question, how does R2 know that R1 is still there? Well, by default, and we can adjust this, by default, we're going to have R1 send a hello message over to R2 every 3 seconds. This exchange of hello messages lets R1 and R2 know about one another and know that they're still there. And if we haven't heard from R1 for a period of time, which is by default 10 seconds, R2 is going to say, I think I probably need to take over. But normally, we're going to have PC1 send traffic up through R1 to get out to the internet. But if something does happen to R1 and R1 goes down, then after 10 seconds by default, we're going to have R2 take over as the active router, and subsequent traffic from the PC out to the internet is going to go via R2. That's essentially what a first hop redundancy protocol does for us. Now, later on in this course, we're going to get into a detailed configuration of HSRP, and we'll get into the detailed specifics behind it about how the MAC addresses work and what multicast address we're using and the different versions of HSRP. But for now, in this introductory video, we just want you to understand the distinction between HSRP, VRRP, and GLBP. Now, HSRP, I do want you to know, is a Cisco proprietary protocol. If you're in an all Cisco environment, this might be your first hop redundancy protocol of choice. If you're in a mixed vendor environment, however, you might turn to VRRP. That's Virtual Router Redundancy Protocol. It's very similar in its mission as HSRP. We're still going to have this virtual router to which we point, and in this example, we still have a default gateway of 10.1.1.1 assigned to that virtual router. Something's different here, though. Notice the gigabit 0/1 interface on R1. Did you notice that that's the same as our virtual router's IP address? That's right. That's something that VRRP can do that HSRP cannot do. We can have the physical interface of a router be the virtual router. And if R1 goes down, we'll say that R1 is the master. We don't say active with VRRP. It's the master router instead of the active router, and it's a backup router instead of a standby router. But if R1 goes down, R2 can take over servicing that virtual IP address. Now, you don't have to have the virtual IP address be the physical IP address of an interface. In fact, I kind of think it's the best practice not to do that, but you can, and I wanted you to know that that's a possibility with VRRP. And the hellos work a little bit differently. Instead of having a hello time, which defaults to 3 seconds with HSRP, we have an advertisement interval used to communicate between our routers with VRRP, and it defaults to 1 second. And instead of having a hold time that defaults to 10 seconds, we have something called the master down interval. And again, in an upcoming video, we're going to dive deep into VRRP, and we'll go through the calculation of that master down interval. It's a little bit convoluted. We have to calculate something called the skew time, and we'll get into all that later. But for now, just realize that we're advertising to one another every 1 second. And it works just like HSRP does, in that normally we're going to be going through R1 to get out to the internet. But if something happens to R1, R2 is going to take over as the master router, and subsequent traffic to the internet is then going to go through R2. Now, we've got one other first hop redundancy protocol to talk about. And it's also Cisco proprietary. So out of these three that we're talking about HSRP, VRRP, and GLBP. VRRP is the only one that is an industry standard. The others are Cisco proprietary, but this one honestly is my favorite. And the reason GLBP is my favorite, Gateway Load Balancing Protocol, is that in addition to giving us redundancy, it, as the name suggests, gives us load balancing. And here I'm giving you a basic example of just two clients and two routers. Now, we still have a virtual IP address of 10.1.1.1 that we're pointing to as our default gateway for both of these PCs. But when a PC wants to go out to the rest of the world and it knows the IP address of a default gateway, it has to also learn the MAC address of that default gateway. And how does it learn that? It sends out an ARP broadcast, an address resolution protocol broadcast, to say, hey, can somebody tell me the MAC address corresponding to this IP address? And with HSRP and VRRP, as we'll get into in a later video in this course, there is a MAC address that gets handed out based on the HSRP or VRRP group number. But here, with GLBP, we're going to give different answers to the same question. I mean, think about this. What if PC1 pointed to R1 as its way out to the internet? And what if PC2 pointed to R2 as its way out to the internet? Now, they're both pointing to the same default gateway. They're both pointing to 10.1.1.1, but what if they pointed to different MAC addresses? Maybe PC1 pointed to the all1's MAC address. That's R1. PC2 pointed to the all2's MAC address. That's R2. That would give us, in addition to redundancy, that would give us load balancing. And there is a router with GLBP that hands out these MAC addresses. It's called the Active Virtual Gateway, or the AVG for short. When it receives an ARP broadcast saying, hey, can you tell me the MAC address corresponding to this virtual IP address? One time, it might hand out R1's MAC address. The next time, it could hand out R2's MAC address. And by the way, you can have a maximum of 4 routers in this GLBP group, so we can hand out the MAC address of R3 and then R4, and then go back to R1, R2, R3, R4, and so on. It could go in a round-robin cycle, which is the default, by the way. And that's going to give us some load balancing. So in this example, R1 is the AVG. But both routers, R1 and R2, they're capable of forwarding traffic off of the local subnet out to the rest of the world. So those routers are given the name an AVF, an active virtual forwarder. They're capable of forwarding traffic off of the local subnet. Now let's go through an example. Let's say that PC1 wants to get out to the internet, so it's going to send an ARP broadcast up to R1, our AVG, our active virtual gateway, and say, hey, can you tell me the MAC address for 10.1.1.1? R1 gets that, and then it's going to respond by saying, yeah, the MAC address is the all1's MAC address. PC2 is now going to ask the same question of our AVG. It's going to say, hey, what's the MAC address of 10.1.1.1? But this time the response is different. This time it says, oh, that's the all2's MAC address, which is R2. That means when PC1 wants to get out to the internet, it's going to be going to the all1's MAC address of R1. And when PC2 wants to get out to the internet, yeah, you guessed it, it's going to go via R2's MAC address, the all2's MAC address. That's the distinction between HSRP, VRRP, and GLBP. Now with GLBP, I said by default we're going to be doing a round-robin load balancing. Well, let's talk about the other options. The default is we'll just take turns. We'll go to the first router in the group and the second and maybe the third and the fourth. Again, we can have a maximum of 4 routers in this group. But you might have a situation where, for whatever reason, you want a specific host to always use a certain router, if it's available, to get out to the internet. So we could have a rule set up, a host-dependent rule that says this host is always going to use this gateway, or it's going to prefer to use this gateway to get out to the internet. Or maybe we have routers with different capabilities. We've got a very high-end router, perhaps. It's got a lot of horsepower. Maybe it's one of the newer 3rd generation ISR routers, like one of those 4000 series routers. And maybe we've got some older routers as well. Maybe we've got a 2800 series router sitting around that's not nearly as powerful. Well, what we can do is distribute the load based on the router's capabilities. We could do weighted load balancing. For example, if I assigned a weight of 50 to R1 and a weight of 100 to R2, then that means my active virtual gateway would be handing out R2's MAC address twice as often as it would be handing out R1's MAC address, which has half the weight, a weight of 50. That's going to give us weighted load balancing. And again, later on, we're going to talk in depth about the configuration of HSRP and VRRP, but the Encore exam blueprint doesn't ask us to know how to configure GLBP. You'll get into the configuration of GLBP if you continue on in your studies. For example, if you go after the CCIE Enterprise Infrastructure Lab, that's a time where you would learn more about GLBP. But for the Encore exam, I want you to know what these three FHRPs are at a high level that we've covered in this video, and then in upcoming videos, you're going to learn the details and the configuration and the verification for HSRP and VRRP.